on brain-oriented programming. Write code that's compatible with how your brain works. The 1956 paper, The Magical Number 7 plus or minus 2, is the most widely cited paper in the 126-year history of the journal Psychological Review. The author, George A. Miller, is considered one of the founders in the field of cognitive science. His historic claim is that you can only juggle between 5 and 9 things in your brain at any one time. To my knowledge, despite some controversy over the years, this 7 plus or minus 2 figure has withstood the ongoing reproducibility crisis, and it appears to capture a deep truth about how our brains actually function. Many people are skeptical of the claim because 7 sounds like an absurdly small number. Surely, if you are doing something complex like writing software, or planning a wedding for that matter, you are juggling dozens to hundreds of things. As it turns out, you are not, at least not at once. In 2005, Lu Chao recited 67,890 digits of pi, a mind-boggling demonstration of a gifted and well-trained mind. Yet, given a series of random-digit single numbers, he can, on average, recall less than 9 of them. To be exact, he's been measured to have a digit span of 8.83, which fits perfectly within Miller's finding. Amazing. Chao memorizes pi the same way storytellers once memorized long tales about Gilgamesh. He can only juggle a handful of things at one time. I find this actually to be very comforting. He is not a freak of nature, or at least not as freaky as you first thought. The illusion that we can hold many things in mind is almost identical to the illusion that our field of view is high resolution everywhere. It's incredibly compelling because the instant we wonder what's over there, we do a quick saccade and are immediately rewarded with a high resolution view of exactly what's over there. We ask the question and we get an answer, so it feels like the answer was there the whole time. Thinking in general works very much like vision. This is not surprising since it's implemented using the same brain hardware. As we rapidly flit from idea to idea, from concept to concept, we page in the necessary details. But at no time do we have more than about 9 individual things in the front of our minds. How do we navigate a complex world with this seemingly crippling limit on the size of our working memory? 2 of the primary tools that we use are chunking and hierarchy. When we think of a car, we naturally divide the car into a handful of high-level chunks like the engine, the dashboard, the seats, the wheels. When we mentally zoom into the engine, however, it effortlessly resolves into more parts. The engine block, the piston, the spark plugs. And we can keep zooming in, although how far we zoom in highly depends on how much we know about cars and the world. In object-oriented programming, one of the simplest ways to tame complexity is to limit your objects to around 7 attributes. In some language, attributes are called member variables, or fields. Many programmers immediately balk at this suggestion. Sure, that works for toy examples, but I'm writing serious software, and my objects sometimes need 10, 20, or 50 attributes. You must be working on easy stuff, they will say. My problems are special, so my code has to be different. The biggest trap of software development is that it's easy, trivial in fact, to write software that you yourself cannot understand, and in turn no one else can understand. Even a novice, especially a novice, can in a few weeks write software that literally no one on the planet can easily think about or reason about. That's depressing, but also kind of impressive in a way. With great power comes great responsibility. Objects which have too many attributes are a major cause of software that's too complicated to understand. Some people conclude the problem is object-oriented programming itself. This is not a crazy idea. There are other ways to program, and they do have advantages. But in my experience, most of the flaws attributed to object-oriented programming stem from having done it poorly. And boy, is it easy to do poorly. The key thing to realize is a single object with a lot of attributes is itself not object-oriented. Instead, it's a 1970s-style structured program in disguise. The attributes of the object are the global variables of the program, and the object's methods are the program's functions. Every function can freely access every global variable, which is what causes many of the problems. A structured program with more than 7 global variables is trouble. And if many objects in your program are effectively messy structured programs themselves, you are in serious trouble indeed. At a high level, you are doing object-oriented programming, but at a low level, you are right back in the 1970s struggling to deal with one confusing program after the next. How do we save this sinking ship? We save it by actively and aggressively keeping the number of attributes per object at or below 7. If you fail to do this, you are punting the problem to your future self, a problem that by definition your future self is going to have a hard time solving. Just today I had a Python class called perfEvent with these 8 attributes. Since 8 is only 1 over the limit, should we wait until the object grows bigger? No, let's deal with it now. To reduce the number of attributes, we introduced 2 new classes or structs, span and origin. Each only has 2 attributes, but now the original object has been slimmed down to 6 attributes. All is well again. Although it's a minor change, compare the 2 versions. The improved one simply looks better, even if you stand far back and squint. It seems minor, but if you don't make these types of changes as you go, it will eventually lead to intractable complexity. The type of complexity that causes projects and companies to fail. The type of complexity that seduces humans into wasting billions of dollars every year writing software that does not work. The benefits of introducing sub-objects go far beyond just reducing the number of attributes. While accessing the attributes is slightly more verbose, I like the sound of span start nanoseconds compared to just start nanoseconds. But more importantly, we can now pass spans and owners to functions, slimming down and chunking their argument lists. We've introduced 2 natural and useful concepts that will pay ongoing dividends. But even better, don't just think of how your code is today. Think about how it's going to grow over time. Your single monolithic object has sprouted 2 buds. You can now push functionality down into these buds, and they can grow into branches, which can later sprout buds of their own. For example, we can give span a getDuration nanoseconds method. Again, it seems minor, but writing getDuration nanoseconds is better than writing n nanoseconds minus start nanoseconds, especially if you're going to do that in many different places. The real magic, though, is that the benefits of being disciplined will accrue like compound interest as you convert your monolithic object into an intricately structured tree which buds and sprouts and branches organically. You will benefit from this better design every minute you are working on the software, and the software will benefit greatly from your improved mood and ability to sustain focus. Code, like most human-created artifacts, can be beautiful, so there is an aesthetic payoff here. But the real jackpot is that if you assiduously tend and groom this tree, you will create a software design that slides into your head with minimal fuss and friction, and slides similarly into the heads of other people. It's no accident that we find natural environments to be more soothing than the made world, than the concrete jungle. The design of the natural world tends to be more in harmony with how our brains think about that world. Game recognizes game. Over time, you will grow a system that you and others can understand, maintain, debug, and extend. When people look at your code years from now, maybe in the far future, they will benefit from your diligence and hard work. And the punchline is doing all this is not hard. In fact, it's much easier to do this work than to not do it. It's easier and more pleasant to work with something that's well crafted and simpatico with your thinking. It's hard and unpleasant to constantly wrestle with something you don't understand. Trim, prune, and shape your objects early and often. Your brain will thank you. Thank you. Bye.